Hello and welcome back to our next lesson in geometry. Today we are on 1-3 section part A. It's broken up into two parts. So today we're going to talk about distance, and then tomorrow we'll get into the second part of this lesson. So distance. Distance is our way of finding how far it is between 2 points, right? We know that word distance, like how far is the distance from your house to the school. It's a length that we can measure something in. And we're going to do that in geometry to find the distance between 2 points. A point that we can refer to as the first point, or x1 and y1, and a second point that we call x2 and y2. And so the distance formula here, and be mindful for a sec, this is gonna seem intimidating, but we're gonna make it easy. The distance formula itself is d equals, the distance equals the square root of the difference in the x values, so we're gonna put x2 minus x1, and then square it, plus the distance in the y values. So we're going to put y2 minus y1, also squared. Let me bring my square root all the way over now. So that is the formula. It is quite lengthy. But with that said, this formula is derived from something that I'm gonna say quotes, you don't know yet because we haven't talked about it, but I think a lot of you have already done this before in middle school. The Pythagorean theorem. Pythagorean theorem, which is the formula a squared plus b squared equals c squared. And if you look, if I kind of just do a little bit of change right here, right? If I just solved for c, so to solve for c, I have to square root both sides. And I'm gonna move this. We're gonna move the c up front. The square root of c squared is just c, which leaves me with the square root of a squared plus b squared is equal to c. Well, look, c is the distance. A squared is just the difference of the two x's, and then b squared is the difference of the two y's. So these two formulas mean the exact same thing. So honestly, thinking about the Pythagorean theorem actually makes this a lot easier. And so let's actually look at this first example. First example says find the distance between the 2 points on the graph. So let's start by using our distance formula, and then I'll do it through the Pythagorean theorem. If I'm going to do the distance formula, the first thing I need to do is I need to determine what these 2 points are. So remember, for graphing points, we're going to start on our x-axis. So I'm going to go left 1, 2, 3, 4, 5 units. And then I'm going to go up 1, 2, 3 units. So this point is at -5, 3. The second point, we're going to go to our origin. I'm going to move left first, so left 2 units, and then down 1, 2, 3. So -2, -3. So I can take these 2 points now, and I can plug them into this formula. So we'll make this my x1, y1, and we'll make this one my x2, y2, and go ahead and start plugging that in. So I've got distance equals the square root of x2 minus x1. So I have -2 minus -5 squared. And then we'll do our y's, put my plus sign and do y2 minus y1. So I have -3 minus 3. Again, put my squared on that, and then bring my square root all the way over and close that out. So this is where you'll see mistakes happen a lot. Anytime that mistakes do happen with the distance formula, it's because using this formula right here, the addition gets messed up right here. -2 minus -5. Well, you have to remember that if I have 2 minuses in a row, or 2 negatives in a row, that becomes a plus sign. If we subtract a negative, we get an addition problem. So it's -2 plus 5, which is going to give me 3. So now I have 3 squared. Over here I have -3 minus 3. Well, since both of those have negatives in front of them, we're really just adding them together, but getting a bigger negative, a larger negative integer. So -3 and -3 adds together to give us -6. So I have -6 squared. Notice I kept the parentheses on this -6, but I dropped the parentheses right here. Well, when it's positive, I don't have to really worry about that because a positive number squared is still a positive number. So 3 squared gives me 3 times 3, which is 9. But over here, -6 squared, well, that negative, when I multiply a negative by a negative, remember the multiplication of 2 negatives makes a positive number. So -6 times -6 gives us positive 36. A good hint for you, if you ever get to this step and have a negative number, you have done something wrong. These should always give you positive values because distance always has to be a positive number. We can't end up with a negative under this square root or it's not going to work. So when I add 9 and 36 together, we get 45. Now, I could just put that in my calculator and get a decimal. It really didn't clarify in this example, which we want to be mindful of. If it said, give the exact answer, well, I need to use my radicals for this. And that's going to be something you may need to practice, an Algebra 1 skill that might be coming back to haunt you. We got to practice that. I got to think what perfect square goes into 45. And I know that 9 is that perfect square, so I'm going to rewrite this as 9 times 5, right? 45 is equal to 9 times 5. Well, from there I can say the square root of 9 is 3, so I can pull it out of the square root. 5 doesn't square root evenly, so I leave it in, and I get 3 square roots of 5 as my answer. It also could say, though, round to the nearest some value. Let's say round to the nearest hundredth. Well, if it says that, I need to make sure that I actually go into my calculator, take the square root of that value, and in this case, I'm going to get 6.708, so 6.71. So both of these answers are correct. You just need to be mindful. If it says find the exact answer, we want that. If it says round to the nearest hundredth, we want that. Like I said, though, this is just one way we could solve this. We could also use the Pythagorean theorem. The way the Pythagorean theorem works is we look over here and say, okay, well, if I turn this into a right triangle, how big is the base? Well, the base is 1, 2, 3 units. So I'd do 3. So we'll put a squared plus b squared equals c squared here. So I'd put 3 squared for my a. And to find b, we'd count how tall the triangle is. 1, 2, 3, 4, 5. 5 squared. And that equals c squared. Well, this is going to solve the exact same way as over here. 3 squared is 9. 5 squared is... Did I, hold on. 1, 2, 3, 4, 5. What did I do? Hold on, I messed something up. I just can't count. 1, 2, 3, 4, 5, 6. That's all, y'all. I just can't count. Don't be me. 1, 2, 3, 4, 5, 6. There, that's the number I wanted. Now it'll match correctly. Sorry. There we go. But that's okay. We all make mistakes in math, learn from them, grow from them, be better from them. I add my 9 and 36 together and I get 45 equals c squared. And again, to get c by itself, we just square root both sides. And now I have c equals the square root of 45. And again, we could then just deliberate what answer we want. The exact answer, we'd simplify to 3 radical 5. And the nearest hundredth, we'd get 6.71. So both options are possible, but you need to feel comfortable with this formula too, because you may see questions that involve using that formula and analyzing someone else using that formula. So both methods are good to understand. So I'm going to come down here and try this one out then. Find a, b, given that a is at -4, 1 and b is at 3, -1. Let's start by doing that as a formula. Distance equals the square root. Again, we'll start by subtracting our x's. Now it doesn't matter which way you go. You can go -4 minus 3, or you can go 3 minus -4. Just whatever you pick, you need to be consistent. So if I do a minus b, I need to do that for the y value as well. And if I do point b minus point a, again, got to consistent with the y value. So I'm going to go a minus b because when I do -4 minus 3, that makes it so I don't have to worry about any minusing negatives. But I'm going to have to fix that in the next one. Because if I did -4 minus 3, I have to do 1 minus -1. -4 minus 3 is going to give me -7. Again, keep that in parentheses. So I know to square the negative out. And 1 minus -1 is going to give me 1 plus 1. So I get 2 squared. And we can go ahead and simplify the negative times a negative is going to be positive. 7 times 7 is 49. And 2 squared is going to give me 4. And when I add that together, I get the square root of 53. So again, we'd pay attention to what our directions said. If it said give us the exact, we'd try and simplify. Square root of 53 does not simplify, it would just stay that way. But if it asked us to give an answer rounded to the nearest tenths, we would end up with the square root of 53 being, sorry, I said nearest tenth, I meant nearest 100ths, 7.28. So again, both answers are correct. This is the exact answer, and this is the rounded answer. So we said we could also solve this using Pythagorean theorem. So let's think about that. If you look at these x values, and this is how we'd use Pythagorean theorem in a problem like this. -4 and 3. Well, how far is -4 and 3 from each other? Well, -4 is 4 units away from 0, and 3 is 3 units away from 0, but they're on opposite sides of 0, right? On a number line, if 0 is right here, well, 3 is here, and negative 4 is all the way over here. So we know that these two things are 7 units apart. So that would be A, 7 squared. B squared is going to be the y's. How far is 1 from negative 1? Well, the same logic applies. If you have a positive and a negative, you're going to ignore the negative and just add them together. 1 plus 1 is 2. So I got 2 squared. The negative 1 from the left side, the 1 from the right side, so they're 2 apart. Work this out, we get 49 plus 4. Add that up, we get 53. And again, square root both sides, and you get the same answer we had over there. Again, both methods work. Just be mindful of knowing how to use this one, even if this Pythagorean theorem one is a little bit easier for you. And our last example is this word problem. In the diagram, each unit represents 1 mile. What is the distance between dock A and dock B? Round your answer to the nearest tenth of a mile. So you can see that we have these two docks. We could find the points if we wanted to. We could also just do our Pythagorean theorem, which definitely on a graph, that Pythagorean theorem is going to be way easier. I'm going to turn the distance from dock A to dock B into a right triangle. And I'm going to ask myself, how far is it from A down to the bottom? So we can count 1, 2, 3, 4, 5, 6 units. And from B to that same point is 1, 2, 3, 4, 5, 6 units or 6 miles. So I know that I'm going to plug in 6 for A, so I have A squared, plus the other 6 for B, so B squared is 6 squared, and set that equal to C squared. 6 squared is going to give me 36. The other 6 squared will also give me 36. Add that together, we get 72 equals C squared, and square root both sides. Again, this one does say, round your answer to the nearest tenth of a mile. So we know exactly what we're doing this one. We're not leaving it up to a guess. We're going to go in there and actually take the square root of 72, and it gave me 8.48. Remember, tenths means I want 1 decimal place, so C is equal to 8.48, so that 4 is going to round up, so 8.5 miles apart, and that would be the distance there. Again, you could do that with distance formula if you wanted to see how that would work. We'd have point A over 6 up 12, so A is at 6, 12, and dock B is over 12 up 6, and we'd put that into our formula. Distance equals the square root of x, so 12 minus 6 squared, plus the y's, so if I did 12 minus 6, we have to do 6 minus 12. And hopefully you can see what's about to happen here. Oh, you can't see because it's at the very bottom. Let me move that up. 12 minus 6 is going to give me 6. 6 minus 12 is going to give me negative 6, so I have negative 6 squared. But that's still going to give me positive 36 and positive 36, which adds up to get me the square root of 72, and I would end up with 8.5 again. So same answer either way, just be mindful of both of them and how you can apply them. And that will bring us to the end of distance. As always, if you have any questions, please make sure you bring them to us and let us know, and we will see you at the next lesson. Bye.